You're welcome back to this channel. So in today's class, we want to show how we can derive the derivative of x raised power n by the first principle of differentiation. The first principle of differentiation will be, let's say y, you know that y is equal to f of x, right? Now, if f of x now is equal to x raised power n, basically the y dx by the first principle of differentiation is equal to the limits as delta x or change in x tends to 0, then f of x plus change in x minus f of x, everything divided by change in x or delta x. So we can see that f of x is equal to x raised power n. So what is now f of x plus delta x? Will be anywhere we see x, we are going to put x plus change in x there. So it will be x plus change in x raised to the power of n. You know, f of x is equal to x raised to power n. So remember. So we now, let's substitute these equations inside the differentiation here. So dy dx will now be equal to the limit as delta x tends to 0. So x plus change in x raised power n minus f of x, and our f of x is what? X raised to the power n. Everything divided by change in x. I just substituted the values f of x plus change in x, which is equal to x plus change in x raised power n, and f of x a, which is equal to x raised power n. So I substituted everything there. Now let's use binomial expansion. So we say that by binomial theorem, if you want to expand x plus change in x raised power n, it will be equal to x raised power n plus n multiplied by x raised power n minus 1, then delta x plus n into bracket n minus 1, everything over 2 factorial, then x raised power n minus 2, then delta x squared plus it continues. Now we now substitute this value, this equation, that is the expansion of x plus delta x raised power n inside the dy dx. So our dy dx now becomes the limit as delta x tends to 0. So x raised power n plus n multiplied by x raised power n minus 1 delta x plus n into bracket n minus 1 over 2 factorial, then x raised power n minus 2 into bracket change in x squared plus dot dot dot, then minus x raised power n, everything divided by change in x. So from here we can see that this positive x raised power n will cancel negative x raised power n. So dy dx becomes the limit as change in x tends to 0, then n multiplied by x raised power n minus 1 delta x plus n into bracket n minus 1 over 2 factorial, then x raised power n minus 2, then change in x squared plus dot dot dot, everything divided by change in x. So from the numerator we can factorize change in x out because it's common to all of them. So dy dx will now be equal to the limit as delta x tends to 0, then change in x into brackets n multiply by x raised to the power of n minus 1 plus n into bracket n minus 1 over 2 factorial, then x raised to power n minus 2, then change in x plus dot dot dot. You know, have factorized one out, so it remains one change in x. Everything raised over change in x. So this change in x in the denominator will cancel change in x in numerator. So dy dx becomes the limit as change in x tends to 0, then n multiplied by x raised to power n minus 1 plus n multiplied by n minus 1 over 2 factorial x raised to power n minus 2, then change in x, then it continues. So delta as x and delta x tends to 0. It means that wherever I see delta x now, I'll put 0 there. So dy dx be equal to the limit as delta x tends to 0, n multiplied by x raised to power n minus 1 plus n multiplied by n minus 1 over 2 factorial x raised to power n minus 2 multiplied by 0 plus dot dot dot. So anything multiplied by 0 will give me 0. So I have dy dx is equal to n multiplied by x raised to power n minus 1. And that is the general formula for differentiation. General formula for differentiation. Differentiation will be dy dx, which is the same thing as f prime of x is equal to n multiplied by x raised to power n minus 1. So if you are giving your y to be equal to x raised to power n, so you can quickly say that dy dx is equal to, you take the power, the exponent, you use it to multiply the coefficient of x here, which is 1. So n multiplied by 1 is n, then x. This power, you now subtract 1 from it. That is general formula for differentiation. Till I see you in the next class. Bye bye. God bless you. Thank you.